So class, today let's discuss naman isotonicity, right? So what is isotonicity all about? So for us, for me to be able to explain this to you guys, okay, let's have a something that I think na naranasan nyo na rin naman. Okay, na-try nyo na ba kasi mag-swimming? Siguro naman sa dagat or sa swimming pool, either of the two. You've tried, right?
Yes po.
All right, good. Okay, especially pag pool. All right, good. Okay, na-try nyo na mag-swimming. Na-try nyo na buksan yung mata nyo sa dagat or di kaya sa swimming pool. Diba, swimming kayo, tapos gaganon ka. Walang goggles. Buksan mo lang yung mata mo.
Yes
Right.
po.
Di ba? Ayan. Right, very good. Anong pakiramdam, class? Pag binuksan yung mata nyo ganun, pagkatapos yung umahon. Mahapdi. Very good. At masakit. Okay. Right? So, class, that only shows to us that the water in the swimming pool, okay, at the same time, class, yung tubig sa dagat, okay, it's not isotonic because you're feeling pain. Nakaramdam ka ng sakit. Or di kaya, class, ito na lang, maganda example din eh. Na-try nyo na bang, habang nag-swimming kayo, parang nataranta kayo, tapos bigla nyo nasinghot yung tubig? Okay, nasinghot yung tubig ng dagat. Or di ba, ang sakit dito, ang sakit niyan sa sinuses. Right? You're going to feel pain, class. Right? That only indicates, class, that those kinds of water are not isotonic. Okay? Meaning, class, yung concentration niya is too concentrated to the point na nada-damage yung cells natin, inducing a sensation of pain. Right? It induces sensation of pain. That's why, class, it's important that most of our pharmaceuticals, especially yung ginagamit sa eyes, sa ilong, at kahit, class, sa bloodstream natin, should always be isotonic para hindi ka makaramdam ng pain habang dumadaloy, halimbawa, yung gamot or yung swero sa inyong veins. O di kaya kasi pag nag-eye drops ka, okay? Pag naglagay ka ng eye drop, dapat wala kang maramdamang sakit. Okay? So pag may naramdaman ka sakit, class, it only indicates that that solution is not isotonic. Okay? So, what is isotonicity all about ba, sir? Okay, so to start off, class, our objectives for today will be to differentiate between the terms isoosmotic, okay, isosmotic, hypertonic, and hypotonic. Okay, apply physical principles in the calculations of isotonic solution. Now, you'll deal with this class more on physical pharmacy, which you will be having next year. Okay, so this is something I'm teaching right now, okay, sa mga ates ninyo, okay, na second year. So physical pharmacy, pinag-uusapan namin to, class, in greater details. Okay, yung mga parameters na ginagamit and how to compute for isotonicity. Pero for you guys, we'll just start with the basic muna. Okay, just an idea what isotonicity is all about and some basic computations. And the last class, to perform calculations required to prepare isotonic compounded prescriptions. Okay? Now, ano ba ang prinsipyo, class, na involved sa tinatawag nating isotonicity? Okay? The principle behind this, class, is what we call osmosis. Are you guys familiar with osmosis? Familiar kayo sa term na to? Medyo? Okay? What about diffusion, class? Oops. Familiar ba kayo sa mga terms na yun? Diffusion versus osmosis. Okay. At yung iba, nag-search muna, ano nga ba pinagkaiba ng isa sa isa? Okay? I think this is something you've learned sa chemistry, sa Gen Chem. Okay, diffusion versus osmosis. Okay? Tandaan nyo lang dito, class, ha? Ang nagkakatalo kasi lang dito is the movement of either solute or your solvent. Solute or your water. Since mas common naman ang water as solvent, eh. Okay, diffusion, class, is the movement of solute molecules from an area of high concentration to an area of lower concentration. Sige, sulat natin yan. Kasi dapat naintindihan nyo muna to, eh. Movement of solute from high to low concentration. Okay. Let me show you an example, class, okay, of diffusion. Paboritong example to. Kunwari, face-to-face class tayo. Okay? Umutot kunwari ako. Okay, nautot ako. So, kunwari, eto ako. Okay, andito kayo. Alright, kunwari, nakapila kayong ganyan. Face-to-face class tayo. Kunwari lang naman. Okay. So, class, pag ako umutot, asan ang main point of, saan yung pinaka-concentrated yung utot? Obviously, nandito sa akin. Okay, this is me. So, class, yung utot, dito yung pinaka-concentrated. Right? So, ano ba ang diffusion? Sabi natin, diffusion is the movement of solute molecules from an area of high to low. Okay? Yung utot na yun ba, mag-stay lang sa akin? Will it stay within me? Obviously, hindi. It's going to diffuse. Sino unang-unang makakalanghap nun? Okay? Yung nasa first row, nasa second row?
First row.
That's first row. Sila yung unang makakasinghot niyan. So magdi-diffuse yan unti-unti hanggang sa makarating sa second row. Maswerte na yung third row siguro. Baka naubos na ng first at saka second row, langhapin lahat yon. Okay? Pero nagets ba class ang principle ng diffusion? Okay? You get it? So class, diffusion is just simply the movement of solute molecules from an area of high concentration to an area of low concentration. I wish I could show to you an experiment regarding this with the use of a dye. Okay? Ang hirap ipakita sa inyo to. Kaya let's try to think of something that you can easily imagine. Ay, ito na lang. Maganda to. Have you ever tried putting sugar in water? O, nagtitimpla kayo kunwari ng juice. Okay. Huwag mong haluin, class. Huwag mo yung haluin. Okay, hayaan mo lang dito yung sugar. Okay? Pag hindi mo siya hinalo, class, ito yung sugar water. Right? Pag ininom ko yung top na water, yung pinaka-top portion ng water, ano magiging lasa nito? Matamis ba? Matamis na. Matamis agad. Okay, haba, hindi ko hinalo yung sugar, binus ko lang ganon. Tapos hinayaan ko mag-settle yung sugar sa ilalim. Matamis na ba agad to?
Hindi po.
Most likely kasi hindi. Ang pinakamatamis niya nasa ilalim. Okay? Nasa pinakailalim yung pinakamatamis niyan. Right? Not unless of course haluin ko siya. So therefore class, ang diffusion kasi is from an area of high concentration wherein andito yung sugar. Tapos unti-unting umaakyat yan. Okay? So magkakaroon ng layer ng lasa yan. Pinakamatamis, andito sa pinakailalim. Pinaka-least matamis, yung pinakataas. So kung may straw ako, class, ilagay ko yung straw dito sa kaila-ilaliman, sinipsip ko yan, napakatamis na malalasahan ko. Correct? Tama nga ba?
Yes po.
Yes po.
Okay.
Yes po.
Now class, ngayon gawin ko, haluin ko yung buong baso ko. Haluin ko siya. So ito, gagayanin ko. Okay, hinalo ko na yung sugar. Hinalo-halo ko na. So anong nangyayari class sa level of tamis sa any part ng tubig na to?
Equal na, sir.
Equal na. So ibig sabihin class, we have already achieved a state of equilibrium. Okay? Equal na siya eh. Nagkaroon tayo ng equilibrium na tinatawag. Right? Nag-add lang ako ng outside force to facilitate faster equilibrium. Kasi technically class, this system will achieve equilibrium on its own. Hayaan ko yan. Pero it will take time. Okay? It will take time. So ano pwede kong gawin para mapabilis yung equilibrium niya? Una, pwede kong i-steer. Haluin ko siyang ganon. O di kaya class, lagyan ko ng heat source sa ilalim para mas mag-spread yung sugar molecules natin, making the solution sweeter. Right? Now that's diffusion. What about osmosis, class? Osmosis is simply defined as the movement of solvent through a semi-permeable membrane. Okay? Semi-permeable membrane. So look at it this way, class. Ang cells natin, class, alam niyo naman siguro, di ba? The cell is covered by a cell membrane. Sabi natin, ang cell membrane niyan, gawa sa lipids and proteins. Okay? Pwede may carbohydrates na naka-embed sa cell membrane. Pero basically, class, a cell membrane, okay, is a semi-permeable membrane. Semi-permeable membrane. Sir, what does it mean when I say semi-permeable? Okay, ano ba ibig sabihin pag sinabi semi-permeable? Sorry, hindi permeable, it's permeable. Okay, semi-permeable membrane versus a permeable membrane. Right? Now, basically class, sige, kayo muna pala. Ano bang ibig sabihin pag sinabi natin semi-permeable?
Pinipili lang po yung pinapapasok.
Very good, Miss Palad. Okay? So ito class yung type ng membrane na pili lang yung pinapapasok niya. Okay? Kung baka class, choosy yung mga cell membranes natin. Kasi isipin nyo class, kung hindi siya choosy at kung ano-ano lang pinapapasok sa kanya, pinapapasok ng cell membrane natin, pwede yun mag-cause ng death ng cell membrane. So hence class, pili lang yung pinapapasok niya. Right? Pili lang yung whatever solute ang pwedeng pumasok sa cell. Okay? Now class, once there is the existence of a semi-permeable membrane, water is something class that can easily cross the semi-permeable membrane. Water can easily cross cell membrane. Okay? Water can easily cross cell membrane. It can easily go in and out of the cell. Walang problema si water dyan. Okay? Pero class, yung mga solutes, yung mga salts, halimbawa, in and out of the cell, sa tingin nyo nakakalabas yun? Say, for example, here's a molecule of a salt. Dito. So, may salt din dito. Yan, may asin. Asin yung dot-dot na yan, ha? That's NaCl. Do you think, class, salts can easily cross the cell membrane? Katingin nyo lang.
Hindi po.
Okay, very good. Class, technically, hindi siya agad-agad nakakapasok dito. It requires the use of special channels, okay, specialized pores within the cell membrane for it to penetrate. So, hirap yan, class, pumasok at lumabas. Okay? Pero ano class yung mabilis nakakalabas? Ang tubig. It can easily go in and out. Are we clear? So, osmosis, class, is simply the movement of this solvent, specifically water, in and out of the cell membrane or in and out of a semi-permeable membrane. Okay? So, ang goal kasi, class, ng water is always to dilute. Okay? Is always to dilute the solvents or the salt. Alright? So, ibig sabihin, class, kung saan mas concentrated si salt, saan pupunta si water? Halimbawa, gawin kayo ng scenario, ha? Here is a semi-permeable membrane. Okay? Here's a semi-permeable membrane. A, B. Place A, place B. Okay, dito class sa lugar ng A, sabihin natin inside the cell. Inside the cell to, ha? Ang concentration, kunwari, class, ng salt is 10 milligrams per ml. Okay, salt concentration. Right? Ginagamit ko na lang class na example is salt, ha? Tapos, on the outside, dito sa B, ang concentration, class, ng salt is 0.1 milligrams per ml. NaCl concentration. Now, kakasabi ko lang, class, ang goal lagi ng water is to dilute salt. Okay? So, ang movement, class, ng water is from an area of low concentration to an area of high concentration. Water ang gumagalaw, ha? Sa diffusion kasi, sino ang gumagalaw dito? Sino yung gumagalaw? Is it the water or the solute?
Solute.
Very good. In diffusion, class, solute is the one moving kasi walang barrier. Okay, walang naghihiwalay. Nothing separates it from into two spaces. Unlike that, class, in osmosis, okay, ang gumagalaw is water because may barrier tayo, may semi-permeable membrane tayo, which prevents the movement of the solute molecules. Nagets ba, class?
Yes,
Maliwanag ko tayo?
Yes,
Kumbaga,
po.
class, kung ito ang ating, ano ba, test tube ko to. Lagyan ko ng semi-permeable membrane dyan. Yung total amount of salt dito versus sa total amount of salt dito, hindi magbabago. Okay? Hindi sila magbabago kasi merong cell membrane that prevents them from mixing with each other. Okay? So, hindi sila makapag-diffuse. So, ano na lang yung gagalaw ngayon? The tendency is gagalaw yung water. Okay? At ano ang goal ni water lagi, class? Ang goal ni water ay?
Mag-dilute.
Very good. Mag-dilute lagi ng salt. Ida-dilute niya yan para, class, kung ano yung concentration ng salt dito will be equal here to achieve equilibrium. Okay? Pero again, ang gagalaw lang ay ang water. So, in the case scenario, class, that I've given here, okay, sa A or B, saan ang ano ang magiging movement ng water ko? Is it going from A to B or B to A? Ano magiging movement ng water ko?
B to A po.
Very good. So, Miss Palat, it's B to A.
B to A.
Very good. Alright? So, class, yung movement niya is B to A. Bakit? Kasi si water, ulitin ko lang. Okay? Ang goal niya lagi is to dilute the more concentrated area of ang most concentrated area. So, gagalaw si water from point B going to point A. Are we clear? And that movement, class, is what we call osmosis. Alright? Osmosis. So, ang gagawin niyan, class, idadilute niya yung salt within sa A. Okay? Inside the cell. Ito yung inside. Ito yung outside. Okay? For this scenario here. So, ang gagawin niya dyan, class, is yung water will try to dilute A para, class, maging equal na ang concentration ng B at saka A, ng inside sa outside. Para class, ang pressure, ang tinatawag natin, osmotic pressure would be equal. Okay? Right now kasi class, right now, in this scenario, 0.1 sa B, 10 milligrams per ml sa A. Okay? Ang drive talaga kasi ng water is going towards A. So, ang pressure nakikreate, papuntang ganon. Okay? It's from left to right. So, are we clear? Are we good so far? Okay. So, basta class, tandaan nyo ang movement ngayon ng water is going from left to right. So, it creates pressure. Okay? Yun yung tinatawag nating osmotic pressure. Alright? So, ayun na nga yun. So, as I've said a while ago, it's the movement of solvent, specifically water, okay, through a semi-permeable membrane into a solution of higher solute concentration that tends to equalize the concentrations of solute on the two sides of the membrane. Now, once equal na class ang concentration ng inside and outside, okay, nagkakaroon tayo kasi tinatawag na isotonicity. Walang pressure. Okay? Wherein equal lang ang movement ng water in and out of the cell. And that is one thing class that we want to achieve. Kasi kung hindi equal class ang movement ng water, mararamdaman mo yung pressure na yon, and it's going to result to pain or irritation. Okay, sensations of pain. Now, think of it this way, class. All right, think of it this way. Magbubura lang ako saglit. After na pwedeng burahin. Dito tayo burin ka tong diffusion Gawin natin scenario class nung sa mata natin. Right? Sa swimming pool. Okay. So say for example class, ito yung mata natin. Okay. Yan yung mata natin. So siguro ng class, alam naman natin na ang mata natin is covered by a cell membrane, right? It's covered by a membrane. And obviously class, may tubig sa loob ng mata natin. Correct? May water dyan. So there's water here. And of course, class, there are certain amounts of salt within the eyes. Okay? Or solutes, kumbaga. Solute. Now, class, assuming, kunwari lang to. Kunwari, class, actually, ito rin naman talaga 0.9% NaCl ang amount of salt in my eye. Right? That's the amount of salt in my eye. Okay? Now, class, ito ang seawater. Lumangoy ako sa dagat. Okay? Walang suot-suot na goggles, sabihin na lang natin class 10% NaCl ang concentration ng seawater. Kunwari lang, hindi ko sure kung ano talagang concentration ng seawater. Now class, sa tingin nyo, saan ang movement ng tubig? Tandaan nyo, may tubig din yung mata ko Is it going from my eye to the seawater or yung seawater going into my eye?
Eye to the seawater.
Okay, very good. Class, ang mangyayari dito is, yung tubig sa loob ng mata ko, lalabas. Right? Lalabas kasi, again, ano ang goal ni water? Mag-dilute ng higher concentration, mas higher concentration of salts. Dahil class 10% ang salt water within the seawater, so tapos 0.9% lang naman ang amount of salt in my eye, so yung water within my eye class, lalabas. Lalabas, ang tendency ngayon is, nag-shrink yung cells within my eye, causing irritation. Kaya makikita nyo class, namumula yung mata natin, di ba? After mo bukas na ganun. Correct? Are we good?
Yes po.
Okay. Or another example class, magbabad ka sa seawater ng matagal. Ano nangyayari sa balat mo?
Kumukulubot po.
Kumukulubot. Alam mo kung bakit kumukulubot yan?
Mawawalan ng water.
Bakit kumukulubot? Yes, Miss Kitalig, sorry.
Nawalan po yung tubig.
Yes, nawawalan class ng moisture yung skin natin. Napupunta sa tubig dagat. Kasi nga nagmo-move from my skin, yung water inside this, nagmo-move siya palabas. Kasi nga mas concentrated ang tubig dagat in terms of salt content as compared to the salt content inside my body. The body class only has 0.9%, an average 0.9% sodium chloride. So are we clear?
Yes.
Nagets ba? Very good. Okay. Kaya kasi importante, kapag gagawa tayo ng preparation, dapat kung ano yung concentration sa loob ng katawan natin, yun din yung concentration ng salt ng ating preparation. Sorry, may question? Para din po makagrip kapag humawak ng, okay. Kasi nagkakaroon ng nagkakaroon ng kulukulubot yung balat mo para makagrip ka. Okay? I'm not sure kung yun daw talaga. Yun ba talaga? Alright? Pero class, it's mostly because your cells are shrinking. Okay? Now, pag nag-shrink ba ang cell, patay agad? Hindi naman. Makaka-recover naman yung mo. Okay, don't worry. You have a lot of stored water inside your body. Mag-achieve tayo ng equilibrium dyan on its own. Right? So, babalik at babalik yun sa dati. Okay, mag-alala. Pero syempre, class, diba? Lalo na kung mata mo yun, ang sakit nun. O di kaya, yung membranes, yung mucous membranes within the nasal, nasal cavity, halimbawa, suminghot ka ng seawater. Okay? So, pag singhot mong ganun, lahat ng tubig doon lumabas, sumama doon sa seawater, so nag-shrink yung cells ko dito, masakit, you can feel that as a pain. Okay? You can feel that as pain. O di kaya, class, na-try nyo na ba suminghot ng, nakasinghot na ba kayo ng, humihigop ka ng sabaw, tapos, gumanong ka. Okay, di ba dadaan sa ilong? Ang sakit nun. Okay, pero yun naman kasi most likely it's hypotonic naman yung solution. Okay? Alright. So that's osmosis. Now, class, what causes the movement of water? Ano ba yung mga solutes na involved natin dito? Okay, most common class would be the sodium chloride, okay, which is of course an electrolyte. Yun lang naman madalas sa pag-uusapan natin eh. Pero kasi hindi lang naman electrolyte yung ating dito ang ating solute. Okay? We can also have non-electrolytes such as sugar. Okay? Sugar. Right? So it's a solution that contains only one molecule and the osmotic pressure varies with the concentration of the solute. Well, on the other hand, for electrolytes class, it's a solution that contains ions. And the osmotic pressure varies both with the concentration and its degree of ionization. Meaning, if an ion class, ions such as sodium chloride, okay, once it separates, tandaan nyo kasi pag nag-separate si sodium chloride, it becomes two ions. There's sodium, which is positively charged, and chlorine, which is negatively charged. Now, depending on the number of ions class, okay, depending on the number of ions, pwede rin yun maka-apekto sa osmotic pressure. Okay? Sa movement ng water natin. So, the more ions that dissociates, or the degree of ionization na tinatawag natin, okay, mas nagiging malakas ang water pooling capacity, water pooling, pooling na P-U-L-L-I-N-G, a water pooling capacity of your electrolytes. Now, let's say, for example, class, between sodium chloride and zinc chloride. Okay? Ay, sige, sabihin ko na kung ilang ions to. Sodium chloride has 2 ions. Zinc chloride has 3 ions. How did I know? Kasi 1 molecule of zinc plus 2 molecules of chlorine. Nagets ba, class, how I know that 3 ions ito? Are we good? Si sodium chloride kasi, 1 sodium, 1 chlorine. Pag ito naghiwa-hiwalay, zinc chloride, that's 1 zinc, tapos 2 chlorine molecule. Okay? So there's 3 ions for zinc chloride. Question, sino sa dalawang ito, class, mas malakas manghatak ng tubig? Si sodium chloride or si zinc chloride? Yung sa dalawang mas malakas maghatak ng tubig?
Zinc chloride.
Okay, very good. Class, this will be, of course, zinc chloride. Bakit siya mas malakas manghatak? Kasi nga mas marami yung kanyang ions na po-produce. Right? Now, class, when we talk about electrolytes, ulitin ko lang, not only the concentration is a factor here. Okay? Nagiging factor din yung number of ions that dissociates. Are we good? Are we clear?
Yes, bro.
Pero kung non-electrolyte yan, class, laging 1 lang ang ion yan. Like say, for example, sugar, glucose. Ito na lang, glucose versus fructose. Okay? In terms of their pooling capacity, water pooling capacity, ito, 1 ion lang din. Sino ang mas malakas? Okay, sino mas malakas manghatak ng tubig? Si glucose 1 ion, si fructose 1 ion. Okay? Sa tingin nyo. Both sugar, both non-electrolytes. Eh, pag non-electrolyte, isa lang yung ion na pinoproduce talaga nila. Which one do you think will pull more? Pull water more? Okay, sino yung mas maghahatak ng tubig papasok? Is it glucose or fructose? Okay? Just looking at the number of ions alone, class. Just consider that. Wala pa tayong concentration. Okay? Anyone? Napapaisip pa. Alright. Tingnan nyo lang class ha. Ilan ba ang ions ni glucose?
1.
1. Si fructose, ilan ang ion niya?
1.
1 lang din. Technically class, they're both going to pull water at the same rate, at the same strength. Okay? Walang mas mangingibabaw sa kanilang dalawa. Kasi pareho lang sila ng number of ions. But, if we start putting in concentration, kunwari, si glucose, 10 milligrams per ml. Ito si fructose, 1 milligram per ml. Sino ngayon ang mas malakas humatak ng tubig?
Glucose.
Si glucose na. Kasi mas concentrated na siya. Again, class, for non-electrolytes, wala tayong pakialam sa kanilang number of ions kasi pare-pareho lang ang number of ions nila. Magkakataon lang yung class would be sa concentration of the solute. Okay? Are we good?
Yes po.
All right, very good. So thus, solutes that dissociates present a greater number of particles in solution and exert greater osmotic pressure than undissociated molecules. Kaya between a non-electrolyte from an electrolyte class, an electrolyte will pull water more. Okay, kaya nga ang laki ng role ni salt, ni sodium chloride. So are we good? Kasi mas marami siyang ions na dissociate. Unlike that of non-electrolytes, isang ion lang yung kanyang dissociate. Okay? Okay. Kasi class, in your mga quiz, tatanong ko lang naman dyan eh, which of the following compounds will exert higher osmotic pressure? Sino yung maghahatak ng tubig na mas malakas? So I'll just give example. Glucose, zinc chloride, mga ganyan-ganyan. Tapos maglalagay ako kunwari concentrations. Mga ganyan-ganyan. Tapos pipila kayo. Is it A or B? Okay? Okay. Now, this one class, I won't be discussing in a lot of detail. Okay? You'll learn more about this in physical pharmacy. Pero these are some of the properties class of solution that can affect isotonicity. So we have, number 1, osmotic pressure, which is our main discussion for today. Okay, yun nga, osmotic pressure. Next one is vapor pressure. Okay, this one class is the pressure exerted when the liquid or your water is converted to its vapor form. Okay, how much pressure is it producing? Then we have, of course, boiling point and then freezing point. Okay, now these properties are interrelated and a change in any of them will result to a corresponding change, okay, in others. But again, for today class, our main focus will be more on osmotic pressure. Okay? Now, what do we mean when we say isoosmotic naman? Okay? Sinasabi natin class, isoosmotic ang isang system, okay, when two solutions with the same have the same osmotic pressure. So meaning if this is my test tube, okay? Ito ang aking cell membrane. May cell membrane sa gitna. Nilagyan ko ng cell membrane. Ang in and out movement ng water natin class is equal. Meaning the pressure of water going in is equal to the pressure going out. Are we clear? That indicates class that the system is in equilibrium. Are we clear? Now class, if a solution or a system is isoosmotic, then class, it's going to create greater patient comfort, efficacy, and a lot safer to use because it causes less irritation. Are we clear? Are we good? Okay, just imagine class putting concentrated sodium chloride in your eyes. Okay, di ba ang hapdi nun? Kahit yun nga, seawater lang eh. Right, so ang hirap nun. Are we good? Now, what about isotonic class? Okay, sasabi natin isotonic. Now, this one is with regards to a solution. Okay, tandaan nyo ito class ha. Isoosmotic refers to, okay, the osmotic pressure within the system. Within a system. Meaning, pwedeng sa loob ng katawan natin. Isosmotic between the cell, intracellular versus extracellular fluids. Okay, isotonic class is referring to the solution itself. A solution with the same osmotic pressure will create the same osmotic pressure with that of a specific or a specified body fluid. Right? Now, generally, class, ulitin ko lang, ang general isotonic concentration inside our body is 0.9% NaCl. Kaya tingnan nyo, class, ano ang concentration ng swero? Okay, ano ang concentration ng normal saline solution? Tingnan, tanong ko kayo. You can search that using Google. What's the sodium chloride concentration of a normal saline solution. Right? Anyone?
0.9 din po yun, di ba?
Very good. Class, it's 0.9% sodium chloride. That's normal saline. Okay? Ibig sabihin, class, pag sinabi natin normal saline ang isang solution, it means isotonic yung solution na yan sa body natin. Okay? It's not going to cause pain once you start using it. Okay? Halimbawa, ito class, oh. Ito kasi buffered na eh. So, kaya 6.5% siya, 0.65%. This one, I don't know if you, okay, never mind. Salinase, familiar ba kayo? Are you familiar with salinase? Yung nilalagay sa ilong? Pang
Yes.
decongest? Okay, yun. Yun naman kasi pag buffered down solution, may dinagdag na akong various solutes. Kaya na-adjust na ngayon yung concentration ng salt sa kanya. Ang concentration kasi ng salinase is 0.65%. Pero that's because you added some buffering agents, other agents. Tama. Okay, to make it more stable formula. So hence, nababawasan ngayon yung amount of sodium chloride that I need to use. Right? Pero sige, mag-usapan natin yan mamaya. Okay, once we start computing for isotonicity. Pero basically, class, the general isotonic concentration inside the body is 0.9%. Percent. Right? So all isosmotic solutions are not necessarily isotonic. Now, tonicity class measures is a measure of the effective osmotic pressure gradient. So a solution class can either be hypertonic, isotonic, or hypotonic. Okay? Ano bang nangyayari pag sinabi nating, ano bang ibig sabihin pag sinabi nating hypertonic, isotonic, at hypotonic? Okay. Pag sinabi natin class hypertonic ang isang solution, ibig sabihin nito class, yung amount of salt outside the cell, okay, is greater than what's inside the cell. That's being separated by, a semi-permeable membrane. So let me give you an example, class. If this is the red blood cell, sabi natin anong concentration sa loob ng cell? 0.9%. Okay, 0.9% ang salt concentration. Now, assuming class outside the cell is 5% sodium chloride. Okay? So, ang 5% sodium chloride in class, that's already higher or lower than the concentration inside the cell?
Higher.
Higher. Class is very good. This is definitely higher. So, therefore, class, the solution now becomes hypertonic. Hyper, kasi mas mataas siya sa isotonic concentration. So, ang tendency class, yung water within the cell, sabi ko sa inyo, ano mangyayari? Lalabas. Pag lumabas ang tubig sa cell class, ano mangyayari sa cell? Ang cell ko,
Shrink.
okay, magkukuryanot yan. Parang resins. Okay, parang siyang resin. So, it's going to shrink. Alright? And of course, as the cells shrink, okay, so it's going to kill the cell sooner or later pag pinabayaan mo yan. So, it's going to cause what we call irritation. Okay? Magkakos yan ngayon ng irritation. So, the cell either shrinks or what we call crenation. Crenate. So, parang nagiging resin siya. Yun na lang. Okay? It's going to cause irritation, class, in your body. So, halimbawa, class, yung gamot natin, halimbawa, hindi na in-adjust for isotonicity. Sinaksak diretso sa ugat mo. Pag saksak yan, class, diretso sa ugat mo, ramdam na ramdam mo yung hapdi. Okay? Because hindi na-adjust yung isotonicity ng gamot na yon. Normally, class, if you experience, halimbawa, na hospital ka, kasi sinaksakan ka ng gamot, tapos naramdaman mo parang gumagapang, okay, kasi most likely yung gamot na yon hindi na ina-adjust for its isotonicity. Kasi pag in-adjust mo pa for isotonicity, dadami siya. Okay, so kesa tiisin mo na lang, isang saksak lang naman. 2, or 10, I don't know. Okay, so tiis-tiis na lang. Right? Pero class, yung suwero mo, dapat isotonic talaga yun. Kasi nakakabit yun for longer duration of time. Longer periods of time. Right? So that's a hypertonic solution. What about an isotonic solution? Sabi natin, class, isotonic, it's a solution that has the same osmotic pressure as a specified body part. Okay? Depende kung anong body part yon. Each part of our body, class, has a specific, tawag dito, isotonic concentration, pero generally speaking, it's 0.9%. Okay, from head to toe, it's generally 0.9%. Pero just so you know, class, iba rin ang isotonic concentration na ginagamit for eyes, iba yung sa nose, right? Iba yung sa blood, generally 0.9. Okay? So, kung say for example, ito yung cell, 0.9% sodium chloride. Naglagay ako ng solution, binabad ko yung cell na yan, 0.9% din NaCl, yung solution ko. Ano ngayon ang mangyayari sa movement ng water? The movement of water, class, is parehong 0.9. Okay? It can easily go in and out of the cell. Hence, class, pag easily going in and out ng cell yung tubig, we say that it's isotonic. Hindi siya namamaga, hindi rin nagkakranate yung cell natin. So, wala kang sakit na mararamdaman. Okay? It's going to be more comfortable for your cells. And for you, of course, generally. Right? Make sense? Very good. Okay. Okay ba tayo? Goods.
Yes po.
Right. And then lastly, class, hypotonic naman. Paano naman pag hypotonic ang solution? Ito naman, class, less concentrated yung solution ko. So kung ito ang cell, natin 0.9% ulit ang kanyang laman. Yung class, yung solution ko is 0.1%. 0.1%. Okay, tapos 0.9% sa loob ng cell. Sa tingin nyo, anong magiging movement ng water ko? Palabas ng cell or papasok ng cell?
Papasok ng
Very
cell.
good.
Papasok po.
Papasok to ngayon ng cell. So class, pag ang tubig pumasok sa cell, anong mangyayari sa cell natin? Yung cell natin, mamamaga. Okay? Are we clear? So it starts to swell. Now, alam naman natin, class, paano kung nasobrahan naman ng pag-swell yung pag-swell yung ating cells. Namaga ng bongga. Okay? Pag sumobra na maga yung class, pwede siyang
Pwede mag-burst.
very good. Pwede siyang mag-burst, leading to lysis. You familiar with the term lysis? Cell lysis. Ibig sabihin yung cell pumutok or nasira. Okay, this one is correlated to the term cell destruction. Okay? So, napipisa ngayon kasi yung cells. So, it starts to burst. Kaya nga, swell, burst, or to lyse. Okay? So, nagde-destroy yung cell. So, generally, class, ayaw din natin ng hypotonic yung solution. Masyadong poor ang concentration. Why? Kasi it could lead to cell lysis. Okay? Kaya nga, class, ever heard the term hemolysis? Ever heard of this term, hemolysis? Okay? Pag sinabi natin, class, hemolysis, ibig sabihin yung cell mo ay namaga at pumutok. Okay? Specifically, your red blood cells. Kaya siya tinawag na hemolysis. Very good? Alright. So, why do we use isotonic solution? Okay? Kasi, class, when you use isotonic solutions, when they start to get in contact with your tissues, they provide no swelling, no contraction, no discomfort. Okay? It doesn't cause any discomfort kasi yung movement of water is equal. Okay? Hindi mamamaga ang cell mo, hindi rin mag-shrink ang cell mo. So, sakto lang. Okay? And oftentimes, class, isotonic solutions are used when you're administering these solutions in the blood, eye, nasal tract, or other body fluids. Okay? Of course, class, ang pinaka-common use niya would be sa blood, eyes, and nasal tract. Okay? Kaya nga may gumagamit ba sa inyo ng contact lens? Any one of you use contact lens? Meron ba? Mukhang wala. Hindi na kasi lumalabas. Ako, I never tried using contact lens. I find it very uncomfortable. Okay? It's very uncomfortable na hawak-hawakan yung mata. Okay? Tried it once, never tried it again. Okay. So, class, ang contact lens natin, di ba may contact lens solution? At yung solution na yun, pwede mong panghugas sa mata mo. Okay, you can use it to wash your eyes. Why? Because it's isotonic. Okay? It's yung wash na yun is adjusted for the tonicity of the eyes para pag nilagay mo sa mata mo, hindi mahapde. Okay, kaya di ba pag napuwing ka, pwede mo lagyan ng contact lens solution mo. Or may foreign matter sa eyes, you can wash it with a contact lens solution. Okay, kung di mo na kayang Mag-antay, edi tap water na lang, ganun mo. Pero mahapdi siya, di ba? After a while. Makikita mo namumula yung mata mo if you just use tap water. Right? Because it's not isotonic. So some special considerations, class, isotonic solutions are better tolerated by the patient than those at extremes hypo or hypertonic solutions. Okay, which makes sense. In most instances, preparations are isotonic or nearly so are preferred. Okay, hanggat maaari, we prefer to use isotonic solutions, especially for the nasal tract, eyes, or sa blood. Drawing fluids out of edematous tissues and into the administered solution, except for those ones. Okay, let's say for example, meron kang edema. Are you familiar, class, with the term edema?
Narinig na po before.
Ayun, okay. Ang Tagalog version kasi ito is pamamanas. Alam niyo na yung pamamanas? Namamanas.
Yes,
po.
Alright, good. Okay, good. Edema, class, is just another term for pamamanas. Normally, nagkakaroon ka ng pamamanas kung ikaw ay buntis. Alright? Common ito, class, sa mga patients na may heart failure or may kidney problems. Okay?
UTI din po.
Pwede rin UTI kasi nang-aapektuhan ng inyong kidneys noon. Especially if your UTI class already going to your kidneys, tinatawag na pyelonephritis. Okay? Or, yun, umakyat na yung bacteria natin sa may kidneys natin, which could affect or cause edema. Okay? So, naapektuhan yung kidneys natin. So, basically, class, you're retaining fluid. Okay? You're accumulating fluid. So, what do you want to do with that fluid, class? Do you want it to stay there or get out? Okay? Halimbawa, pag nagkaka-edema ka, class, ito yung cell mo, marami siyang water dito. There's increased levels of water inside your cell. Kaya nagkakos siya ng fluid retention. Or nakikita mo namamaga yung, yung binti. Ganyan. So what do you want to do with the water here, class? You want to get it out, right? How do I draw it out? Normally, class, you'll use an osmotic diuretic. An example of which, class, is mannitol. Mannitol, class, is it's an osmotic diuretic, obviously. Okay? Pero, class, it's highly concentrated. Anong ginagawa nito, class? Pag gumamit ka ng mannitol, yung fluids within your cells, class, ito kunwari si mannitol. Si mannitol, class, hahatakin niya yung tubig sa loob ng cells mo. Okay? Hahatakin niya yan palabas. Hence, nababawasan yung amount of water inside your cells. Okay? So, are we good? Are we clear?
Yes,
Don't worry, class. You'll learn more about this, class, like diuretics, like furosemide, okay, thiazide diuretics, hydrochlorothiazide, how they work, class, in pharmacology. So, dun yung pag-uusapan ito in more details. Pero the principle behind that, class, is they're simply using the principle of osmosis. Okay, wherein solutes can draw out water. Okay, concentrated solutes can pull water. Right? So what else? Ophthalmic preparations are formulated to be isotonic to duplicate ophthalmic tears for the comfort of the patient. Kaya notice mo rin, class, ang luha, di ba, medyo maalat-alat. Okay, di ba, pag ikaw ay naluha ng okay, when you cry, class, di ba, the luha is, it's quite salty. Okay, because nga, class, you have to maintain a certain degree of isotonicity. And you achieve that through salts. Okay, through sodium chloride. Alright, so buffered at an appropriate pH, both to reduce irritation to the eyes, tissue, and maintain stability of the preparation. Such as this one, class, salinase. Okay, nakikita ba yung salinase? Hindi na makita mo na nga. Okay, class, it's a buffered solution. Okay. Now, injections that are not isotonic should be administered slowly and in small quantities to minimize tissue irritation, pain, and cell fluid imbalance. Kaya notice mo, class, di ba yung mga antibiotics? Okay, na-try nyo na bang sa mga na-hospital na, okay, pag binibigyan ka ng antibiotics sa swero, hindi pwedeng ganyan. Isang ganun na lang. Dapat dahan-dahan lang yun. Dahan-dahan lang, ganyan-ganyan. Kaya kinatsaga minsan ng nurse yan. Kasi nga, they know it's going to cause irritation. Okay, masakit yun na, parang susunog yung ugat mo. Okay, ayun. So, common na reklamo yun ng mga patients pag yung nurse walang kaamor-amor, tapos isang ganun na nagmamadali na kasi marami pang pasyente, halimbawa. Ito, naintindihan ko naman, pero it's going to cause pain to the patient. Okay? So, for intravenous infusion, so large volumes of hypertonic infusions containing dextrose can result in hyperglycemia, osmotic diuresis, excessive loss of electrolytes. So, class, pag gumamit tayo ng hypertonic solutions, okay, like yung may masyadong mataas ang concentration ng dextrose, it can cause hyperglycemia, first and foremost. Tataas ang sugar mo. And it could cause osmotic diuresis. Okay, we're in class, you have an excessive loss of electrolytes. Kasi yung dextrose, hinahatak yung water sa loob ng cell. Okay? Hinahatak niya palabas. Excess infusion naman of a hypotonic infusion can cause naman, yun na nga, hemolysis. Dahil hypotonic siya. Right? Now, this one class is with regards to the number of ions. As I told you a while ago, class, di ba? Okay, ions, number of ions, okay, plays a vital role in osmosis. Okay? It's important in osmosis. Yung sabi natin, the higher the number of ions being produced, mas malakas yung osmotic pressure na nakikreate ng isang substance. Mas malakas siya manghatak ng tubig. Okay? So hence, class, it's important that we consider the number of particles each solute formula breaks into, okay, when it starts to dissolve. And to get that, class, we have the Van Hoff factor. Van Hoff factor, class, ito lang gusto kong maalala nyo dito. Ginagamit yan para malaman kung ilang ions ang magse-separate sa isang electrolyte. Okay, can be a strong electrolyte or a weak electrolyte. Pag non-electrolyte, ilang ions ang pinoproduce? Okay? Whatever that substance may be. If it's a non-electrolyte, very good, Ms. Cruz. Iisa lang ang ion na pinoproduce nun. Okay? Unlike class with electrolytes like sodium chloride, zinc chloride, okay, they dissociate into so many ions. And to compute for that class, we often use the Van Hoff factor. So it's the ratio between the actual concentration of particles produced when a substance is dissolved and the concentration of a substance as calculated from its mass. So it's the calculation of colligative properties of ionic solution requires the use of the Van Hoff factor. Okay? So how do we get the Van Hoff factor? Obviously, class, pag non-electrolyte, wag ka na mag-isip. 1 lang yan. Okay? So non-electrolytes do not dissociate into ions. So hence, class, their Van Hoff factor, or the number of ions it dissociates into, will always be 1. Such as dextrose, glucose, mannitose, sucrose, glycerol, urea, sorbitol. All of these, class, are considered to be non-electrolytes. Pag nakita nyo to, okay, pag nakita nyo to, automatic, pag pinakompute ko kayo ng Van Hoff factor, 1 lang ang sagot yan. Right? Pag yun ang ano. Okay, huwag na kayo mag-isip. Basta yan ay non-electrolyte, 1 lang yung kanyang Van Hoff factor. Right? So an example of which class would be glucose, C6H12O6. Okay? If you dissolve this in water, class, ang mangyayari, glucose pa rin yan. Hindi siya naghihiwalay. Okay? It's still going to be glucose. Hence, we only have the Van Hoff factor will only be 1. What about for electrolytes? Now, kailangan kasi natin itong i-differentiate. Strong electrolytes sa weak electrolytes. Strong electrolytes dissociate into complete ions. Okay? Nagsiseparate talaga yung mga yan. So, halimbawa, pag nilagay ko ang sodium chloride, NaCl, halimbawa, 1 kilogram of NaCl, pag nilagay ko yan sa tubig, class, naghihiwalay siya into sodium and chlorine. Okay? Hindi na siya sodium chloride lang. It dissociates into sodium and chlorine. So hence, class, ilan yung kanyang Van Hoff factor? Ilan yung ions na nag-separate? Okay? So dahil may isang sodium, may isang chlorine, so ilan yung total number of ions that separated? It's going to give you 2. So the Van Hoff factor would be 2. Are we good so far? Yes, makes sense? All right, good. Okay, what about for calcium chloride? Okay? Si calcium chloride naman, class, 1 molecule of calcium, okay, 2 molecules of chlorine. Okay? So dahil, class, 3 yung molecules niya, okay, so si calcium chloride, once na nilagay mo sa tubig, it starts to dissociate into 1 molecule of calcium plus 2 molecules of chlorine. So therefore, it dissociates into 3 ions. Hence, class, the Van Hoff factor would be 3. Right? Now, what about kung weak electrolyte ito? Alright? So, normally, class, pag weak electrolyte yan, it will greatly depend on the percent dissociation. How much of that electrolyte dissociates? Pag sinabi natin, class, weak electrolyte kasi, hindi siya nagkakaroon ng complete dissociation. Unlike that of strong electrolytes, class. Strong electrolytes separates into ions. There is complete dissociation. Pag sinabi natin, class, complete dissociation, naghiwalay ang positive sa negative. Completely. Okay? Talagang buong buo yan. Maghiwalay, positive and negative. Sodium and chlorine, maghiwalay yan. Pag weak electrolyte kasi yan, class, incomplete dissociation ito. Okay? This causes an incomplete dissociation. Ibig sabihin, hindi siya totally maghihiwalay-hiwalay. Right? So hence, class, the percent dissociation here is very important. I won't teach you how to compute this muna. Medyo complicated yung way of computing for percent dissociation. Pero I want you to know right now, class, na pwede yan i-compute. Okay? In our quizzes, class, I'll give you the percent dissociation na. Okay? Bibigay ko sa inyo yan. Pero wag muna natin pag-usapang paano kino-compute. Okay? Medyo technical yung pag-compute niyan. Pero you will learn how to compute that, class. Don't worry. Especially in physical pharmacy. Right? So, tatitignan mo lang, ilang percent ng dissociation, ilang percent ng undissociated. Okay? Normally, class, this one is expressed in percentage. Now, if nagbigay ako ng weak electrolyte, tapos hindi ko sinabi ang percent dissociation, okay lang yon. I-assume nyo na lang, automatic ang assumption dyan is, it's going to be 80% dissociation. Right? It's going to be 80% dissociation. Let me give you an example, class, on how to use this formula for weak electrolytes. Madali kasi pag strong electrolyte eh. Pag strong electrolyte, wala na akong compute dyan eh. Tingnan ko lang ilan ang ions. Ito, sodium chloride, 1, 1. So, 2. Okay, so calcium chloride, isang calcium, dalawang chlorine. So, that's 3. Ang dali, di ba? Pag strong electrolyte. Pag weak electrolyte, let's say, for example, acetylsalicylic acid. Okay? Acetylsalicylic acid kasi sa weak electrolyte. This is your aspirin. Okay? It doesn't completely dissociate into its ions. So obviously, class, titingnan ko lang, ilan ba number of ions ito? Kunwari, 2 ang ions. 2 ang ions niya. Tapos ang percent dissociation, dahil hindi ko alam, assume ko na agad na 80%. So that's going to be 0.8. Okay? So 2 ions times 0.8 plus, ilan therefore ang undissociated? So kung 80% ang dissociated, then that's going to be 0.2 for the undissociated. Correct? To make 100%. Right? So lalabas dyan, 2 times 0.8 will give you 1.6 plus 0.2. You get 1.8 for the Van Hoff factor. Now, class, sa Van Hoff factor, we don't use decimals as much as possible. Lagi natin yan nira-round up. Okay? Okay? So, nira-round up natin lagi yung values, yung mga decimals. So, kung 1.8 yan, automatic, that's 2. Are we clear? Are we good?
Yes.
Okay. Another thing, class, about Van Hoff factor. Pag ito yung ginamit for weak electrolytes, ha, sometimes kasi, class, pag nag-compute ka, ang lalabas is 1.2. Pag 1.2 yan, class, automatic 2 pa rin yan. Are we clear? Basta sumobra tayo ng, basta sumobra yung points natin. Okay? Basta sumobra yan, class, automatic round up yan. Are we good? Are we clear? Kahit 1.1 yan. Pag I mo is equal to 1.1, automatic 2 yan. Okay? Basta sulat nyo lang yung 1.1, tapos itabi nyo yung 2 na yan. Kasi lagi siyang round up. Okay? So for strong electrolytes, ayun na nga, class, oh. So for number of ions, usually 2, 1.8, 2 na rin yan. 2.63. Okay, kung 3.4 yan, automatic 4 pa rin yan. Kung 4.2 yan, kahit 0.2 yan, 5 pa rin yung number of ions natin yan, yung I natin, yung Van Hoff factor. Alright? So for non-electrolytes, always assume 1. So for weak electrolytes, the percent dissociation, okay, should always be considered. So kung 80% dissociated, 20% undissociated, that's a standard. Kung hindi binigay ang percent dissociation. Right? So let me give you an example problem here, class. So I have here zinc sulfate. So zinc sulfate, class, is a 2-ion electrolyte, dissociating 40% in a certain concentration. Calculate its dissociation factor. So sabi lang naman natin, class, ibang dissociation factor is I equals number of ions times percent dissociated, this na lang plus percent undissociated. Okay? So zinc sulfate, given na 2 ions times 40% ang kanyang dissociation. So 0.4. So dahil 0.4 yan, ang undissociated ko would be 0. Ilan?
0.6.
Very good. Very good. It's going to be 0.6. So therefore, 2 times 0.4, you get 0.8 plus 0.6 plus 0.6. Di ba? Dahil ng computation dito. It's going to be 1.4. So sabi natin, pag 1.4, automatic, i-round up natin yan. That's 2. Okay? So the answer class 1.4 or 2. Very good? Okay. Dito naman. Actually, binigay ko na yata lahat ng sagot dyan sa PDF file nyo, no? Nagtago ako. Anyway. So, zinc chloride is 80% dissociated in a solution. Calculate its dissociation factor. Now, this one class, hindi ko binigay yung number of ions. Okay, so obviously class, actually na-mention ko na rin naman to eh. How many ions does zinc chloride have?
3.
3.
Okay, example lang dito. Kasi ang kanyang chemical formula is ZnCl2. Okay, ibig sabihin, isang zinc, dalawang chlorine. So that gives you 3 ions. Right? So now class, since binigay naman na yung percent dissociation niya, so consider na rin natin ito. Kaya importante rito yung pH. Pero pag-aralan na lang natin sa physical pharmacy. Right now, I just need you to understand this. Okay, so I would be equal to 3 times 0.8 plus 0.2. So 3 times 0.8. 2.4 plus 0.2, 2.6. Okay. So that's 2.6, or sabi natin, 3. Alright, so it's 2.6 or, technically, it's 3. Now, you might be wondering, class, sir, bakit importante yung Van Hoff factor na yan? Ba't kailangan ko pang malaman to? Okay, remember, class, the Van Hoff factor is important when computing for colligative properties. Okay, such as vapor pressure. Gamit na gamit, huwag kayo mag-alala, class. Pag nag-physical pharmacy kayo, magsasawa kayo mag-compute ng Van Hoff factor. Okay? Ko-compute kayo ng mga ano. Saan nanggaling yung 0.2 or 0.6? Okay. Di ba, class, sabi natin kanina, yung formula, I equals number of ions times percent dissociated plus percent undissociated. So kung 80% class, right? So in this case, kung 80% ang dissociated, ilan yung undissociated? Okay, kung 80%, it's going to be
20%.
Very good. It's 20%. Bakit? To make 100%. Right? So, pag sinabi kong, in this case kanina, yung example natin dito, 40% dissociated. Dissociating 40% in a certain concentration. So, 40% yung dissociated niya. So, bakit 0.6 ang ginamit ko?
Kasi 60% po yung ginamit.
Very good. Kasi 60% yung kasi 40% dissociated. So therefore, ang matitirang undissociated would be 60% to make 100%. Alright? Okay lang yan, Mr. Kitalik. At least, na-clarify ka. Okay, so yun lang naman yung class. Tandaan nyo lang, when we're dealing with percentage, okay, kasi di ba in a weak electrolyte, so I don't know, kasi dapat na-discuss to sa Gen Chem nyo, pero most likely, baka sinabi lang, hindi, matututo nyo sa higher pharmacy. Okay, well, true enough naman, tinuturo ko rin. Kung ako nagtuturo class ng physical pharmacy, I still teach this. Okay? In a weak electrolyte kasi, it's partly ionized, partly unionized. So, ibig sabihin, parts of it can dissociate, while some parts of it does not dissociate. Okay? Kumbaga, they stay in their molecular forms. Okay, ang hirap i-explain pag hindi, pero basta yun na yun. Pag sinabi ng dissociate class, naghihiwalay siya into ions. So, pag sinabi kong 40% ang dissociation, ang percent dissociation ng isang substance, ibig sabihin, 40% of that substance can separate into ions. While the remaining 60% will exist as is. So kung salicylic acid yon, 60% will remain as salicylic acid. Hindi siya magbabago. While the remaining 40%, which dissociates, nagde-dissociate siya into its ions. Okay? Nagbe-break apart siya. Okay? So I hope that makes sense. So basta lagi to make 100% ito. Okay, Docs? Okay. So hopefully yan siya. So in this case, yun. So it's 2.6 or 3. Okay, so again, class, bakit importante yung Van Hoff factor na to? Okay, it's because, class, it's important for adjusting for our colligative properties. Again, sabi ko sa inyo, sa physical pharmacy, magsasawa kayo ito once we start computing for boiling point elevation, melting point, okay, and then vapor pressure lowering, right, stuff like that. You'll learn more about that class in physical pharmacy. Pero right now, dito mo tayo sa tonicity lab. Okay, bakit importante si Van Hoff factor? Kasi kailangan siya class to compute for E-value. E-value class refers to the sodium chloride equivalent. Now, all the time ba, asin lang ang pwede kong gamitin to adjust tonicity? Okay? Now, right now, class, I want you to know, hindi. We can use any chemical to adjust for isotonicity. Basta provided you know its sodium chloride equivalent. Halimbawa, class, wala akong asin. Wala akong asin sa butika ko. Parang malabo mangyari yun, no? Pero kunwari lang naman. Okay? Or halimbawa, ayoko gumamit ng asin as a tonicity adjusting agent. Okay? Gusto ko gumamit boric acid. Okay? Boric acid. Pwede kong gamitin class ang boric acid as a tonicity adjusting agent, TAA. Right? Tonicity adjusting agent. Okay? I can use it as a tonicity adjusting agent as long as I know its sodium chloride equivalent. Are you clear? Kasi kung mapapansin nyo kanina, lahat naman ng discuss sa tonicity, ang gamit natin sodium chloride. So para uniform na lang ang lahat, okay, i-adjust natin yung mga TAAs natin, tonicity adjusting agents, as sodium chloride. Kumbaga, kung sakaling naging sodium chloride siya, ano kaya ang kanyang magiging value? Yun ang importansya class ng E-value or ng sodium chloride equivalent. Nagets? Kumbaga, I'm converting any type of chemical into its sodium chloride counterpart. Right? Very good. Ano yung kanyang equivalent as a tonicity adjusting agent kung sakali siya ay naging asin? Sorry, am I making sense? Okay. Nagets ba, class? Ulit? Isa bang ulit?
Paulit po, sir.
Okay, ulitin natin ha. Notice class, anong ginagamit kong compound kapag tayo ay nag-uusap tungkol sa tonicity? I always talk about
Sodium chloride.
sodium chloride, right? Kasi class, ito yung pinaka-common na ginagamit natin pang-adjust ng tonicity. Sabi natin, isotonic ang 0.9% sodium chloride. Correct? Okay, so limited ba ako sa sodium chloride lang as a tonicity adjusting agent? Hindi. Okay, hindi ka limited class sa asin lang. Pwede kang gumamit ng boric acid. Pwede nga rin papaverin eh. Or any compound class, any chemical compound can be used as a tonicity adjusting agent. Yun nga lang, gusto kong malaman ano ang equivalent niya. If ever I use this, ano equivalent niya as a sodium chloride? Kaya importante class ang E-value. E-value class tells me na say for example, okay, kung sakaling gumamit ako ng 2 milligrams of boric acid, kunwari lang to ha, anong equivalent niya in as milligrams sa asin? Okay, in terms of adjusting tonicity. Nagets ba class? Kino-convert ko yung weight or yung boric acid. Okay, kino-convert ko siya class into what would be its equivalent weight kung sakali siya ay sodium chloride. Okay ba tayo? Okay, sige, mamaya. Bigyan ko kayo ng example para mas maintindihan ninyo. Right? Pero class, gusto ko lang sabihin sa inyo, ang tonicity adjusting agent natin, hindi tayo limited lang sa salt. Okay? We're not limited to salts. Right? So, the sodium chloride equivalent class simply talks about the amount of sodium chloride which has the same osmotic effect based on the number of particles as 1 gram of the drug. Okay? So, sodium chloride class usually used to adjust the tonicity of a certain solution, making it isotonic, right? However, class, as I keep on adding more solutes in a solution, kasi class, ang isang gamot, hindi lang naman asin ang laman yan eh. Di ba maraming laman yan? May gamot, may preservatives, okay, may binders ka pa din nilalagay dyan, all of which can contribute to its osmotic effect. Hence, class, I'm trying to find out ano yung kanyang equivalent as a sodium chloride. Okay? The sodium chloride equivalent class of a substance may be calculated using the following formula. 32.5 class is a constant. This one kasi is with consideration sa molecular weight ng salt together with its Van Hoff factor. Okay? So therefore, 32.5 times your multiply the Van Hoff factor of your tonicity adjusting agent divided by the molecular weight of the tonicity adjusting agent. Okay? Let me give you an example. Tonicity adjusting agent nga pala. So tonicity measures the effective osmotic pressure gradient. The relative concentration of solutes dissolved in a solution determines the direction and extent of osmosis, of diffusion. So, halimbawa, minsan, pwede magkakasama to, sodium chloride, dextrose, glycerin in one preparation, all of which can contribute to osmotic pressure. Okay? Ito halimbawa, class. Ginamit kong tonicity adjusting agent is papaverine. Okay? So, papaverine hydrochloride, its molecular weight is 376, is a 2-ion electrolyte dissociating 80% in a given concentration. Calculate its sodium chloride equivalent. Okay, so sabi, isulat natin given. Isa-isa natin to. Okay? Given. So percent dissociation equivalent to, 80%. Number of ions, 2. Molecular weight, 376. So how do we compute? Ang required natin dito is, tawag ito, sodium, E-value na lang. E-value is unknown. So let's go into the solution. So importante dito class, alam ko muna yung I of TAA, or the tonicity adjusting agent, which is papaverine hydrochloride. To compute for I, sabi nga natin, number of ions multiplied to percent dissociation plus percent undissociated. So ang number of ions natin is 2 times 0.8 plus 0.2. Okay, 2 times 0.8 plus 0.2 is 1.8. Or sabihin natin, 2. Okay, round up na agad natin yan. So, I na natin would be 2. So, E-value class, or the sodium chloride equivalent, sabi natin, that's 32.5 times I of the TAA divided by the molecular weight of the TAA, or the tonicity adjusting agent. So that's 32.5 times 2 divided by 376. And we get 5 times 2 divided by 376. You get 0.17. 2 decimals ng class, okay na yan. So hence class, the sodium chloride equivalent of papaverine hydrochloride is 0.17. But 1.17 yan? Oops, mobra ako. Yeah, 0.17 yan, sorry. 0.17. Okay, check mo na, 32.5 times 2. Antok na ata ako nung ginagawa ko ito kagabi. 376. Okay, 0.17. 0.17. So are we good? Are we clear,
Yes
class?
po.
Okay, nagets ba? Kaya napaka-importante, class, na alam din natin yung Van Hoff factor para ma-compute natin ng E-value. Okay, pero class, alam niyo pagdating, given po ba yung molecular weight? Oo naman. Most of the time given. Kung hindi ko given yan, class, kayo mag-alap, pwede nyo mag-search to. Or you can compute for it, right? As long as you have the chemical formula. You still know how to compute for molecular weight, right? Tama nga ba? O try nga natin, ano ang molecular weight ni sodium chloride? Pero kailangan mo kasi ng periodic table dito eh. Alam nyo, swerte nyo. When I was in college, pinamemorize sa amin lahat ng molecular weight ng mga elements. Pati yung kanilang valences at charges, pinamemorize sa amin. Kasi bawal magbukas ng periodic table noon sa amin. Okay? Pero okay lang, I don't care. I mean, technically, di naman kailangan talaga i-memorize it, but may periodic table, ba't akong papakahirap? Okay, why make life complicated when I can make it a lot simpler? Right? Pero anyway, class, I want you to know na pwede natin compute ang E-value. But, there's a but, okay, if you actually look for, class, i-type nyo lang sa internet, makikita nyo agad yung mga E-values ng mga various tonicity adjusting agents. You don't have to compute for it anymore. You usually have a table of that. Okay, pero just in case lang naman, na kailangan nyo mag-compute, at least alam nyo kung paano. At sa halimbawa, dito may gagawin kayong bagong compound. Right? You want to get its E-value. So, you can easily do that. Okay? So, try nga natin. Ano class ang molecular weight ng ng ating sodium chloride?
58.44 grams.
Okay. How did you get that? Very good. How did you get the molecular weight of sodium chloride? Sorry, sino yun? Hindi ko napansin. Who was that? Tama ka dun, 58. Add. Okay. Ms. Bersosa, add Sodium and chlorine molecular weight. Very good. Kasi class, ang molecular weight lang naman ni sodium is 23.
23 po.
Okay, tapos 35 si chlorine. So, hindi ko memorize yung mga point something nila. Right? So, yun lang ang memorize ko. Usually, rounded off na agad yung inaalala ko sa kanila. So, that's 58. Okay, that's gram per mole. 58 gram per mole. That's how you compute for molecular weight. Pero okay maglalakas, most of the time, I'll just give this anyway. Okay, bibigay ko na yan sa mga problems natin. Okay, kasi importante sa akin, alam niyo kung paano mag-compute ng e-value. Okay? So, halimbawa, kung may 2, 2 dyan, siyempre, kaya nyo i-multiply yan sa 2. Like zinc chloride, halimbawa. ZnCl2. So, that's 2 molecules of chlorine plus 1 molecule of zinc. Okay, here's another example. Calculate the sodium chloride equivalent of glycerin. It's a non-electrolyte with a molecular weight of 92. Okay, how do you compute for this class? So this one, tingnan nyo to ha. Our glycerin is a non-electrolyte. Okay, so given glycerin. Okay, number of ions. Number of ions of glycerin. Obviously, that's automatically 1. Molecular weight is 92. So, ang required ko dito, class, is e-value. No. So, papasin nyo, class, hindi na ako magko-compute ng Van Hoff factor. Bakit? Ba't hindi na ako kailangan mag-compute ng Van Hoff factor?
Non-electrolyte po kasi.
Very good. Automatic na yung class. Since it's non-electrolyte, okay? It's non-electrolyte. So, therefore, class, no need for Van Hoff factor kasi hindi siya magdi-dissociate eh. So, automatic, that's tayo sa e-value. Kaya ang sarap gumamit ng non-electrolytes. It's 32.5 times 1. So, automatic na yun. 5 by 92. So, that's, 2.5 divided by 92. We get 0.35. Right? Easy. Dali, right? Okay, basta given na ako agad ng molecular weight nila. Okay, dokes? Okay, so that's E-value. That's the sodium chloride equivalent. So that's what we do, class, when we're converting a substance like glycerin, okay, to its sodium chloride equivalent. Okay, here's another one. So calculate the sodium chloride equivalent for timolol maleate, which dissociates into 2 ions and has a molecular weight of 432. Okay? Now, in this case, class, timolol maleate, ngayon pa lang sabihin ko na sa inyo, this one is a weak electrolyte. Okay, this guy is a weak electrolyte. So nga, try nyo nga. Ay, hindi nga. Binigay ko na lang kasi sagot dyan eh. Hindi ko binigay. So makikita nyo rin. Anyway, how do we do this now? So, pakita ko na lang. So, sabi are given. Okay? Ang ating given class number of ions is equal to 2. Ngayon, class, tatanungin ko kayo. Since this is a weak electrolyte, ano ang kailangan kong parameters? What other parameters do I need here? It's a weak electrolyte. Para makapag-compute ako ng maayos. Anyone? Ano pang kailangan kong value here? I already have the number of ions. Okay, sabihin natin.
Percent dissociation.
Very good. Okay, thank you very much, Miss Amor? Claudine, sorry. Okay. Or Amor din pala, sorry. Tama. Okay, Miss Claudine. So we have class percent dissociation. And ano ang percent dissociation ko? Since it's not given,
80%.
very good. That would be 80%. All right? And then, of course, class molecular weight, we have 432 given naman na. So required would be E-value. No. So solution natin, kuha muna tayo ng I. So that would be 2 times 0.8 plus 0.2. It's going to give me 1.8 yata to, di ba? Tama, 1.8. 1.8, so sabihin natin 2. Okay, it's still 2. Right. So tapos, i-value na tayo. Okay, so we have 32.5 times 2 divided by 432. 32.5 times 2 divided by 432. Tandaan nyo lang, class, ang I is always a whole number. Okay, yung value factor natin. Give you 0.15. So are we good? Are we clear?
Yes po.
Okay, good. Kasi mamaya, titingnan nyo kung paano ginagamit ang e-value natin. Okay, actually, nung mamaya, ito na pala. So, how do I use now the e-value? Okay, e-value class, kailangan ko yan kung, ito na nga sabi natin, if you're using more than one tonicity adjusting agent. So, ibig sabihin, class, more than sodium chloride na ang ginagamit mo. So, if there are 2 or more, TAA, okay, then I'll definitely need my e-value for each chemical that I'm using. So, the first step, class, would be get the total volume. Ano muna yung total volume ng iyong solution? Obviously, you're making a solution, so that's going to be liquid, right? Tapos sabi natin, class, ano ang concentration dapat ng sodium chloride in a solution to make it isotonic?
0.9.
Very good, Miss Claudine. Okay, sabi natin 0.9%. So 0.9, class, is 0.009. So kunin mo muna first ang total volume ng inyong, okay, whatever the total volume of your preparation is. Kung gagamit ako, class, ng 100 ml, so times 0.09, then that means if I'm going to make a 100 ml solution, 100 times 0.009, I'll need obviously 0.9 grams of salt. Correct? Okay. Now, class, so dapat yun ang total number of salt na meron ako dyan. Okay? So, ang next na gagawin ko yan, class, if I have other compounds, okay, I have other ingredients na hindi salt, kunin ko muna yung equivalent weight niya. Sorry, kaya sodium chloride equivalents using the e-value. So, whatever e-value you computed or kung given ko na. So, that's simply, class, to get the e-value, you just need to multiply the weight of the tonicity adjusting agent or the other agents or kung ano man ang ingredient na ilalagay mo sa solution, multiply it to their E. So kung multiple, magano ka dyan, magsa-sum up ka ng bawat isa sa mga substances na yon, kukunin mo yung E-value at kung ano yung kanyang sodium chloride equivalent. Then you get the sum of it. After getting the sum of it, class, okay, compute for the additional sodium chloride na kailangan mong idagdag. So alam natin ng in the case of 100 ml, kailangan ko is 0.9 grams of NaCl. So assuming lang, class, nakuha ko na yung sodium chloride equivalent ng ibang agents ko, ang gagawin ko na dyan, isa-subtract ko lang dyan. So 0.9 grams minus kunwari lang naman, 0.2 grams. Okay, so 0.9 minus 0.2. Kunwari lang to, class, ha. So ang dadagdag ko na lang would be 0.7 grams ng sodium chloride. Okay? And so if you are to use other TAAs than sodium chloride, okay, whatever tonicity adjusting agent that you'll be using, you'll just need to, the number of sodium chloride to be added divided by the E-value of whatever it is, whatever tonicity adjusting agent ang gagamitin natin. So mahirap mag-explain ng ito ng walang example. So let me give you an example, class. Here is a preparation. Okay? Ang gagawin ko dito, class, is, given ko ng E. Right? I've already given the E. So ang gagawin natin dito, class, is, gagawin natin siyang isotonic. Okay? So most likely, class, since this one contains ethylene chlorobutanol, okay, most likely gagawin itong eye wash. Okay, gagawin ito sa mata. So gagawin natin siyang isotonic. Notice, class, anong gagamitin kong tonicity adjusting agent? I'm not using salt here. Okay, what I'm using, class, will be dextrose. Paano ko nalaman na dextrose ang gagamitin kong tonicity adjusting agent? Kasi may QS. Remember what does QS mean? To add sufficient quantity. Okay? QS add. Until I make it isotonic. So in this case, class, I'm not using salt. So how many dextrose should be used in compounding the prescription? Okay, how much dextrose do I need to put to make it isotonic. Right? Now, ang una ko titingnan dito, class, is, susulat ko muna yung given ko. Right? Ano ang total volume? Ano ang total volume ng aking prescription? Ng aking compound? Should be? Anyone? Ano ang total volume natin? Okay, class, pag sinabing add, okay, ibig sabihin mag-add ka lang ng rose water until you make 50 ml. Right? Okay. Are we good so far? Okay pa ba kayo?
Yes po.
Okay. Pag sinabi natin class QS add, okay, sufficient quantity, QS means sufficient quantity. Add meaning, whatever the resulting concentration, just add enough of this, like rose water, okay, add enough rose water to make 50 ml. Meaning the total volume of my solution should be 50 ml. So are we good? Okay. Okay, ah. Okay tayo. Okay, so ang first question dito is, how much, kung sakaling salt ang gagamitin ko, di ba? Sabi natin, lagi salt ang basehan natin eh. How do I make this isotonic? A 50 ml solution. Okay? So to make this isotonic, class, so this now solution. Okay, so isotonic. So gagawin lang natin is 50 ml times 0.009 na sodium chloride. So 50 times 0.009, I'll need at least 0.45 grams of NaCl to make the 50 ml solution isotonic. Correct? Are we good so far? Okay. Okay. So now, dito ko na didiretso ha. How do I get now, class, the sodium chloride equivalent of ephedrine? Kasi given na to, ito na kumbaga yung prescription eh. Gusto ko lang malaman how much ang equivalent ng 0.5 grams of ephedrine kung sakali siya ay salt. So since given naman ang e-value ko, ano lang gagawin ko? Okay, because I'm using more than 2 salts. Anyone? All I need to do is, oh, come on. Okay? So class, based sa ating formula, it should be multiply lang. Alright? So yung weight, class, ng ating ingredients, i-multiply natin siya sa e-value niya. So kung gagamit ako ng 0.5 grams ng ephedrine, ano kaya ang equivalent niya in terms of osmotic property sa sodium chloride? Okay, ano yung weight na equivalent niya sa sodium chloride? So that's 0.5 times 0.29. And you get 0.145 grams. Meaning, class, 0.5 grams of ephedrine is equivalent to 0.145 grams of sodium chloride in terms of their osmotic property. Is that clear? Kaya napaka-importante, class, ng sodium chloride equivalence or yung e-value natin. Maliwanag ba? Okay? Sorry, hindi ko kasi makita ang mukha nyo. Hindi ko alam kung okay na ba o hindi. Or just say, class, sabihin nyo lang. Okay, isa pa. So, class, tandaan natin ha, lahat ng idadagdag mo sa isang solution, okay, isang solution halimbawa, lahat ng ingredients na idadagdag mo, it's going to affect its osmotic property, correct? Correct. Meaning its pooling capacity. So the more ingredients na idadagdag ko, class, sa isang solution, dumadami yung concentration niya. So pag dumami ang concentration ng solution na to, mas malakas siya ngayon manghatak ng tubig. Correct? Okay. Ang ginagawa lang natin ngayon dito, class, is, kasi ang kailangan natin would be sodium chloride, right? It's equivalent as a sodium chloride. Kasi sabi natin, ang isotonic na sodium chloride is 9%, 0.9%. We know that 0.9% sodium chloride is considered to be isotonic. That's isotonic. Okay? That's isotonic. So, ibig sabihin, ang osmotic pressure that is created by 0.9% sodium chloride, okay, would be equal all throughout. Hindi mag-shrink, hindi mamamaga ang cell natin. Okay? So therefore, class, since I'm adding ephedrine, chlorobutanol here, okay, it's going to affect the osmotic property of my solution. Yung pooling capacity niya ng water. So para class, mas ma-gets ko siya, convert ko siya, kung sakaling halimbawa yung ephedrine na to, ano kaya yung kanyang weight in terms of sodium chloride? Kaya nga tayo meron tayo tinatawag na sodium chloride equivalence. Okay? So kumbaga, I'm just converting ephedrine. What if ephedrine is a salt, is a sodium chloride? Okay? So kaya, andyan class yung e-value natin. Kaya napaka-importante ng e-value na yan. So ibig sabihin nito class, since I multiplied the weight of my ephedrine to its e-value, 0.5 grams pala of ephedrine is equivalent to 0.145 grams of sodium chloride in terms of its osmotic property. Okay? Very good so far? Okay. Ngayon, gawin ko rin yun sa chlorobutanol kasi it's another ingredient that I added na nagdadagdag din sa osmotic property ng ating solution. So, 0.25 times 0.18. So, yun yung kanyang e-value. It's equivalent to 0.045 grams. Okay? Okay. Now, class, yun yung ingredients na nagdag ko. Ano ang tonicity adjusting agent ko here? Normally, ang tonicity adjusting agent natin is sodium chloride. Salt. Normally. Pero sabi ko nga sa inyo kanina, hindi tayo limited sa asin lang. We can use any compound as a tonicity adjusting agent, provided I know their e-value. So in this problem class, ano ang aking tonicity adjusting agent?
Dextrose.
Very good. It's dextrose. Okay? So kumbaga siya yung gagamitin kong pang-adjust ng tonicity ko. So right now class, ang gagawin ko muna is, kunin ko muna ilan yung total value na salt. Okay? Ilan ang total value ng ng mga solutes ko kung sakali siya ay naging salt. So I'll add simply ephedrine, this step 1. Ito yung step 1 kanina. Step 2 class, add ko yung tawag ito, sodium chloride equivalents, NaCl equivalent ng mga solutes. Mga solutes na ginamit ko so far. So right now, class, I'm using ephedrine and chlorobutanol. So that's 0.145 grams plus 0.045 grams. And that's going to give me 0.19, correct? 0.19 grams. So yung dalawang solute ko na gagamitin, ephedrine and chlorobutanol, pag pinagsama ko sila, 0.5 grams of ephedrine plus 0.25 grams of chlorobutanol will give me an equivalent of 0.19 grams of sodium chloride. Right? This is a NaCl equivalent ng dalawang solute ko. Okay? So sabi natin class, to make the solution isotonic, a 50 ml solution isotonic, it needs to have 0.9% of sodium chloride. At kinompute natin kanina, to make 50 ml isotonic, I need to put 0.45 grams of salt. Sodium chloride, correct? So ang next step ko dito class is get the amount of tonicity adjusting agent needed. Okay, and how do I compute for that? How do I get the amount of tonicity adjusting agent needed? So ang gagawin ko lang dyan class is 0.45 minus 0.19 grams. Okay? And therefore, 0.45 minus 0.19 is going to give me 0.26 grams of salt. Ito ang kailangan kong salt of sodium chloride. Nagets ba kas kung paano ko siya na-compute? How I was able to arrive to. Okay, good. So meaning class, I'm going to need to use 0.26 grams of sodium chloride. Okay? Okay. Pero class, am I going to use sodium chloride as the tonicity adjusting agent?
Di po.
Hindi. Gagamit ako dextrose. So therefore, class, remember here, okay, in this formula here, the tonicity adjusting agent to be added, if you're not using sodium chloride, in this case, we're not going to use sodium chloride. We're going to use dextrose. So class, ang gagawin mo lang is, the number of sodium chloride to be added divided by the E value of the tonicity adjusting agent. So hence class, lipat natin dito. Okay, amount of TAA, okay, would just simply be 0.26 grams divided by 0.35, which is the tonicity adjusting agent, the sodium chloride equivalent of dextrose. So 0.26 divided by 0.35, we get 0.74 grams of dextrose. So are we clear?
Yes po.
Okay. So now class, ano ngayon ang gagawin ko para maging isotonic ang solution ko? So ang gagawin ko lang dyan class is, so ang compound ko would be, okay, based on the prescription ha. So ang gagawin ko ngayon class is, in a graduated cylinder, maglalagay ako ng 0.5 grams ng ephedrine, maglalagay ako ng 0.25 grams ng chlorobutanol, then class, ang QS na to, magdadagdag ako ng 0.74 grams of dextrose. Okay, so kung ito yung graduated cylinder ko, ayan. So, lagay 0.5 grams ephedrine, HCl. Tapos lagay pa ako ng 0.25 grams chlorobutanol. Tapos maglalagay pa ako ng 0.74 grams dextrose. Okay? Then kung ito yung 50 ml mark, okay, QS add na lang ako ng rose water. Alright? Rose water. Okay. To make, tas ang magiging resulting solution nito would be now considered as isotonic. Very good. Now, there's a question here, class. Okay, Mr. Legaspi. Saan daw galing yung 0.45 na to? Yung 0.45 na yan, class, nanggaling dito. Di ba? Sabi natin, kailangan maging isotonic ang ating solution. So, the total volume of our solution is 50 ml. Correct? Ito nabanggit natin kanina. Sabi natin, to make that isotonic, dapat it should have a concentration of 0.9% sodium chloride. Correct? Okay, so kung 50 ml ang solution ko, ilang sodium chloride dapat ang gagamitin ko? So simply class 50 ml times 0.009, okay, you get 0.45 grams. This is the amount of sodium chloride needed to make the solution isotonic. Okay? So class, pag nag-compound ka ng isang isotonic solution, yan ang gagawin mo. At ang kalalabasan niya, class, kahit i-boost ko yan sa mata ko, adjusted para sa mata to eh. Okay? So pag binoost ko yan sa mata ko, okay lang ako. Goods pa rin. Okay, docs? Yan, kaya 0.74 grams of glucose, dextrose ang kailangan ko dito.